Okay, we're doing Module 2, Lesson 6. Today is 9/29/20. Our objective is to connect area models to standard algorithm using partial products. It's a lot like we did on Lesson 5. And as long as you took good and careful notes on multi-digit multiplication, this shouldn't be too much of a challenge. There's two different ways that we're going to solve these. We're going to solve with an area model, and then we're going to solve with a standard algorithm. Okay, so when you're doing an area model, we know basically there's always a box, right? Every time you're drawing a box. When we did lesson 5, we just put 73 on top, and then we took the 60 and the 4 and we broke it up. Well, this time I want you to go ahead and break up every place value. So we're breaking up everything by place value. So we've got 70 plus 3 and 60 plus 4, and I know to draw my lines where I'd put the plus sign. All right, 7 times 4 is 28. Add on the 0, right? I'm just going box by box. 4 times 3 is 12. 7 times 6 is 42, but there's 2 zeros. And 6 times 3 is 18, but there's 1 0. Now I need to find out the partial product that belongs here and the partial product that belongs here. 280 plus 12 is easy for me to do in my head. That's 292. This one's a little harder to do in my head, but I'm going to go place value by place value starting from the back. So ones, I have 0, 0. Tens, I have 8 and 0. Hundreds, I have 1 and 2. That gives me 3. And then I have 4,000. Now I have two partial products, and I'm going to add them. Make sure you're careful to line up your place value, right? So 2 plus 0 is 2. 9 plus 8 is 17. 2 plus 1 is 3, plus 3 is 6. Bring down my 4. And that's the answer I have to 73 times 64 in an area model. Now they also want us to do it in a standard algorithm. So I'm going to take my top number and put it on top. And take my bottom number and put it on the bottom. Whatever's on top here is on top here is the first number here. Whatever's the second number is the side number is the bottom. Now I have 3 times 4 is 12. Look at 12. 4 times 7 is 28, plus 1 more is 29. And then I'm going to draw an arrow and go, yay, this partial product matches that partial product. That's what we're doing, connecting the area model to the standard algorithm with partial products. Okay, don't forget our super important step 2, because we're now in the tens place, we need to put a 0 so that all my next step of multiplication is shifted over into the tens place, not stuck in the ones place. Then I can do 6 times 3 is 18. 6 times 7 is 42, plus 1 more is 43. Yay, this partial product matched that partial product. And then step 4 of multi-digit multiplication is adding them together. 2 plus 0 is 2. 9 plus 8 is 17. 3 plus 3 is 6. Bring down the 4. Yay! We did it. That's multi-digit multiplication using an area model and a standard algorithm. I'm going to show you the same thing, only with a 3-digit. So let's say we were solving 814 times 39. So remember, in the area model, every time you have a box, I'm going to put the 800. Remember, I'm separating them all by place value. Plus 10 plus 4, right? So that's my 800s, 10 ones. 10 tens and 4 ones, right? Everywhere there's a plus sign, I knew to make my box. And then I have 30 plus 9. Now I can just do the simple multiplication. 8 times 9 is 72, but there's 2 zeros. 9 times 1 is 9, but there's 1 0. 9 times 4 is 36. 8 times 3 is 24. And I have 1, 2, 3 zeros. 3 times 1 is 3, but I have 1, 2 zeros. And 3 times 4 is 12, and I have 1 0. Now I'm going to come up with my partial products. I know that this is a little bit tricky, but you got to go place value by place value. So make sure I'm looking at all the ones. 6 plus 0 gives me 6. Now I'm looking at the tens. 3 plus 9, that's 12. So I'm going to remember there's one more in the hundreds carried up, right? Now I'm looking at hundreds. 2 plus that 1 from the 12 gives me 3. Now I'm looking at thousands, and I have a 7. Okay, same here. I'm looking at ones place. 0 plus 0 plus 0 gives me 0. Look how I'm careful to line them up. Tens place. 2 plus 0 gives me 2. Hundreds place. 1 plus 3 plus 0 gives me 4. See how I'm careful to line them up? Thousands place, I have a 4. And 10,000s place, I have a 2. Then I can add them together. 6 plus 0 is 6. 2 plus 2 is 4. 3 plus 4 is 2. 7 plus 4, 7, 8, 9, 10, 11 is 11. And 2 plus 1 is 3. Now, did we get it correct? Let's do the standard algorithm to see. So we'll do 814 on top, 39 on the bottom. First step is to do the ones place. 9 times 4 is 36, right? Yeah. 9 times 1 is 9, 10, 11, 12. 9 times 8 is, gosh, my brain's slow today. 9 times 8 is 64, 65. No, that's not right. 9 times 8 is 72. Yes, 9 times 8 is 72. Plus 1 more is 73. Yay! Partial product, match. Okay, don't forget the super important step. When we deal with this 3, we are in the tens place. So we have to put a 1 there in the ones place so we don't accidentally do any math in the ones place. 3 times 4 is 12. 3 times 1 is 3 plus 1 more is 4. Notice how I'm crossing off the stuff I already used. And then 3 times 8 is 24. Yay, matching partial product. You've got to draw the arrows, right? And then we add 6, 4, 3, 4 plus 3 is 7. 7 plus 4 is 11. 2 plus 1 is 3. Yay! Okay, so I want you to make sure that your notes match mine. And then when you do the problem set, you'll see that all you're doing is a standard algorithm. The directions are telling you to draw an area model, solve using standard algorithm, use arrows to match. So when I draw my box, I want to make sure I leave room for math over here, right? And I have 40 plus 8 and 30 plus 5. I'm putting a line at the plus signs. Okay? And then my goal is to have a partial product here and a partial product here and a final answer here. And I should be drawing an arrow from here to here, from here to here, and this should match this. Now, when you're solving this, don't forget to put the 0 on the second row of multiplication. That's the biggest mistake students make, is to forget to put that 0.